Hi, this is Mr. Doherty. I am talking about motion maps, mainly for people that weren't in class while I went over it and we talked about how to do motion maps. Let's start with a scenario. I've got this car here, and here is our motion detector. Okay, motion detector here, and our car is sitting right there. So the first thing that we want to do in this scenario is understand that the motion detector is what we're going to call position is equal to 0. That's the first thing that we need to do. So position is equal to 0 there. Then we got our car. And let's just say, for this example, let's say our car moves this way until about there at a constant rate, and then it stops. And that's it. So it starts and then it stops for a little bit, and then the time interval is ended. So we can represent this in a different way other than drawing this motion up here. That's called using a motion map. And a motion map looks something like this. Well, there's little ticks here. Doesn't matter how many. And so the first thing we need to do is the far left line, I'm going to put 0 meters there. Okay? Or 0 anything, any measurement unit. I guess I haven't specified what the unit length measurements are, or position measurements. So we're just going to say 0 and indicate any position measurements there. Then I'm going to notice that each one of these are ticks. Now, I can make them anything. I can make them 5 meters, 10 meters, whatever. But since it's a problem, it doesn't specify, I'm just going to leave them blank. So the first thing we need to do to figure out our motion map, the motion map basically tells us where the object is at every given time interval. So typically on a motion map, I have to do this delta t is equal to some number. Okay, and so we could be looking every second. Well, if I'm looking every second, if I write 1 second there, then I'm going to put a dot down every second where it is. So let's say it starts at 0 seconds. Let's say it starts not at 0 because it's not at 0. It's not right on top of the motion detector. Let's say it starts right here. So I'm going to put that there. And right underneath that, I'm going to write T start. Or T is equal to 0, just to indicate that that's our 0 time. Okay? So then every second, I'm going to put a dot. Well, since we don't really specify, I can do however many dots I want. So let's just say it went for 3 seconds. So 1, 2, 3. And as I'm going, my position is changing. So this line right here, this black line, represents the position. These dots are representing where that object is at a given position. Okay? In every second. So it's not just jumping from one spot to the other, it's moving at a constant rate. And so to represent the rate or the velocity that it's moving, I use this arrow right here. And there's another way to do this. I said it was a steady rate, and so these guys should all be equal. Tick, tick, tick. Equalization marks show me that those guys are moving at a constant rate. Okay? Well, now the car has moved at a constant rate, then suddenly it stopped for a few seconds. So at this point right here, it's not moving. So after 1 more second, where's it going to be? Well, right there at that same position. So I'm just going to start stacking them on top of each other. And I can keep going until however long it takes. Now, a couple key things about, that would be the motion map for this example. A couple key things. First off, velocity is represented by arrows. And dots represent the position at a given clock reading. So position at clock reading. All right. I do hope that this helps your understanding of the motion maps. Please use this for the rest of Lab P.2.2 motion detectors.